solving the problems of JEE Advanced 2017, and will go up to 2021. So if you didn't watch the previous video, so you can watch this in my playlist. This playlist will be there, so you can watch the previous video from the playlist. So yeah, this one, question 37 and question 38, was in the previous video. So we are going to solve these two problems in this video. So question 39 and question 40. So each video contains two solutions. So each video contains two solutions. Previous video has two solutions, question 37 and question 38, and this video will contain these two solutions, question 39 and question 40. So yeah, let's do that. Yeah, this is the problem. So the problem says that the x box x with the greatest integer less than or equal to x. Yeah, we know that this function box x, which is a function which gives the value, the integer value, which is less than or equal to x. Suppose x is 1.5, x equals to 1.5. So the box value of x is equal to 1, which is the greatest integer less than or equal to 1.5. So this is the integer value. Now then, at which point the function, here a function is given. So the function is fx is equal to x cos pi into x plus box x. So the function is given here. So we are going to check at which point the function this is discontinuous. So we know that a function is discontinuous at a given point if the left hand limit and the right hand limit and the value at that point, if this 3 is not equal, then we can say that the function is discontinuous. So here we will check the left hand limit and the right hand limit at each point of this. So the points are given as at, if we check option A, if this is true or not. So we'll check if the function is discontinuous or not. So at x equals to -1, we'll check the left hand limit. So limit x tends to -1 minus, so this is the left hand limit of this point, x cos pi into x plus box x. So we'll check if this gives which value. Like it is the left hand limit, so left hand limit of -1, which is less than -1, right? So the value of less than -1 will be -1 cos pi into -1 plus, now the value which is less than -1, similarly less than -1 value, so the box of that value will be -2, which is the integer greatest integer less than or equal to the value which is less than -1. So the value here will be -2, right? So the value ultimately gives us -1 cos -3 pi, right? So this ultimately gives us minus 1 into cos minus 3 pi gives us minus 1, right? So the value of cos minus 3 pi, which is nothing but this pi minus 3 pi, right? So it will be clockwise rotation. So this minus pi, again minus pi, this value here it will be minus 1, right? So the value will be ultimately equal to 1. So the left hand limit at the point x equals to minus 1 is equals to 1. Now we will check the right hand limit at the same point. So at this point the right hand limit will be limit x tends to minus 1 plus x cos pi into x plus this equals to, now this is same, minus 1 cos now here pi into minus 1. Now in this case the value will be like it is from the right of the minus 1, so the right of the minus 1 is greater than minus 1, right? So this value will be nothing but minus 1. So this is minus 1, so this will be minus 1 cos minus 2 pi. So cos minus 2 pi will give us this, nothing but cos 0. So cos 0 right? So this is cos 0 minus pi minus 2 pi. Cos 0 is nothing but 1, so this will be minus 1, correct? So we can see that the left hand limit of this point is not equal to the right hand limit at this point. So at this point the function is discontinuous. This proof. So at x equals to 0 the left hand limit x tends to 0 minus. So if left hand limit and right hand limit is equal, then the function will be continuous, otherwise it is discontinuous. So limit x tends to 0 minus fx equals to limit x tends to 0 minus x cos pi into x plus box x. So this will be nothing but 0. Now we'll put 0 over here. So 0 cos pi into 0 plus, now the value which is tends to 0 from the left hand side. So this is 0 over here, and this is which is 0 minus, and this is which is 0 plus. Like left hand, from the left hand side we are approaching to 0, which is 0 plus, and the 0 minus is the right hand left hand side we are approaching to 0, and this right hand side we are approaching to 0. This is the positive, so this is left right hand limit, and this is the left hand limit. So for the for the left hand limit, the box x which is less than 0 will be always equals to minus 1. So it is minus 1. So it will be minus 1. So 0 cos of minus pi. This will be 0 cos this is 0 over here, and we multiply 0 with something, so it will be obviously 0. Now we'll check the value x tends to 0 plus fx. So this will be limit x tends to 0 plus x cos pi into x plus box x, and this is 0 cos pi into 0 plus now the value which is tending from the right hand side, so this value is tending from right hand side, which is something like 0.5 or something, so the value box value will be obviously 0, so here it will be 0, so this is nothing but 0, so 0. So you can see that the left hand value and the right hand limit and the right hand limit is equal, and this is equal to 0. So in this case this will be continuous, so this is not in the answer, so this will be continuous at x equals to 0. Now we'll check at x equals to -1 it is continuous or not. So we'll check the next page. So for x equals to x equals to 1, for the value x equals to 1, this is continuous or not. So we'll check limit x tends to 1 minus, so the left hand limit, so limit x tends to -1 fx is equal to limit x tends to 1 minus x cos pi into x plus box x, right? So this is the function over here. So 1 cos pi into, again this value 1, so 1 minus, so this is 1 and 1 minus is less than 1, so yeah, so 1 minus is nothing but it will be 0, so this is 1 plus 0, so this is equal to cos pi, so 1 into cos pi, so 1 into cos pi is equal to -1. You know that the value of cos pi is equal to -1, so this will be equal to -1. Again the value limit x tends to 1 plus fx, so this value is equal to limit x tends to 1 plus x cos pi into x plus box x. Now this is 1 cos of x pi into x is equal to 1, and this is equal to also 1, so 1 plus is this, so 1.5, the box value of 1.5 equals to 1, so this will be 1 again, so yeah, cos 2 pi, this will be cos 2 pi, so if this is cos 2 pi, so for this value cos 2 pi value is equals to 1, so we can see that -1 is not equals to +1, so left hand limit is not equals to right hand limit, so this is discontinuous again, this is discontinuous again, so this is discontinuous. Now we'll check for the value x equals to 2 over here. So for x equals to 2, for x equals to 2, limit x tends to 2 minus, so this is left hand limit, fx equals to limit x tends to 2 minus x cos pi into x plus box x, this, so 2 into cos pi into, this is 2 again, and this is nothing but 1, so this will be 2 cos 3 pi, right? So this is cos 2 plus 3 pi, correct? So this is nothing but cos 2 plus 3, so this is 3 pi, so 3 pi is this pi and pi is nothing but this cos pi, so cos pi value is -1, so this will be -1, so minus 2. So this is equals to 2 into minus 1. So this is minus 2. Again, if we consider the right hand limit, so limit x tends to 2 plus fx is equal to limit x tends to 2 plus x cos pi into x plus box x. So this will be equal to 2 cos pi into 2 plus 2. So this is 4, right? Pi and pi. So this will be cos 0. Cos 0 value is 1. So this will be equals to 2, right? So again this 2 is not equal. So 2 not equals to minus 2. The left hand limit and right hand limit is not equal. So this is discontinuous again. So this is discontinuous. So we got our options like here A, C and D are the correct options. So we'll move forward to the next question. So next question is question 40, I think. The question is given, question 40. So question 40 says that here f is a continuous function. So if is a continuous function from R to the real number, domain is real number, so real number to the open interval 0 1, the continuous function, then which of the following function has the value 0 at some point in the interval 0 1. Now if the following function has a value 0 at some point in the interval 0 1, then there is a root of that function. So if like this, so there is a root. How? Because if the value of the function is 0, sub value 0 at some point in the interval 0 1, then obviously there is a root in that interval. If there is a root in the interval, by Bolzano's theorem, it states that if a continuous function has a root in the interval, in an interval, then the sign will be changed at the ending point. The sign will be opposite sign. So we'll check if the sign of f0, and again we'll check the sign of f1. If the sign is changed, then we can say that there is a root. So if there is a root, then there must exist a value, like there must exist some point in which in the interval 0 1 at which the value will be 0, that is there will be a root, correct? So we'll check for each function if the sign at the starting point and at the ending point will be same sign or opposite sign. If there is same sign, then it is not possible to have a root, therefore the value cannot be 0 at any point. But if there is a sign change, that is the sign is opposite, then yes, there must have a root. So we'll take it as gx for the function. So gx for each function we will take and we'll solve. Now for this one we'll take, for the first one, for a, we'll take gx equals to x to the power 9 minus fx. So if that is so, we will calculate G0. So 0 to the power 9 minus f0. Now it is clearly written that if the range of the f is 0 1, so f0 lies between 0 and 1. Again, so if f0 lies between 0 and 1, it must be negative, less than 0, sorry, less than 0, because it is 0. So 0 minus f0, it must be less than 0, negative. But G1, if we can calculate G1, 1 to the power 9 minus f1, which is 1 minus f1. Again, f1 lies between 1 and 0. So yeah, this is between 1 and 0, and if you subtract this value, like between 0 and 1 value from 1, then you will get obviously greater than 0 value, because it is less than 1. f1 is less than 1, the maximum value of f1 is less than 1, so 1 minus this value is obviously positive, so this will be positive. We can see that G0 is negative and G1 is positive. So as per Bolzano's theorem, we can say that yes, the value at some point in the interval 0 1 will get a 0 value, the value 0. So Gx must have a 0 in the interval 0 1. So this is true. Again, we'll check the next one, which is B. So if we take Gx equals to x minus 0 to pi by 2 minus x ft cos t dt, then G0 value is equal to this will be 0, nothing but 0. So we'll put something like it's easy. We'll put 0 in the place of x, so we'll get minus 0 to pi by 2 ft cos t dt. So this value must be positive value. So because this is from 0 and 1, this value ft is from 0 and 1, lies between, and cos t lies between minus 1 and actually cos t lies between minus 1 and 1, but in this interval, like from 0 to pi by 2, if t varies between 0 to pi by 2, then obviously cos t lies between 0 and 1. So yeah, this will be obviously positive value, so we'll get positive value, and this is negative, so this will be negative. Again we'll consider the value G1. So this will be 1 minus 0 to pi by 2 minus 1 ft cos t dt. Again, for this value we'll get, like, yeah, this is 1, and this is something like this. Also this one, again this one is like 0 to ft and this one is cos t is from 0 to 1. Again, for the minimum value, this is the maximum of this will give us the minimum value of G1. Now we'll consider the minimum value as always, so we'll consider the maximum value for this. So the maximum value for this will be pi by 2 minus 1. The maximum value is this, pi by 2 minus 1, correct? So this will be 2 minus pi by 2. So this is obviously positive. Yeah, so this will always be positive. So this is G0 is negative and this is positive. Again this is also true. So some zero value will occur at some point in the interval 0 1. So this is also true. Now we'll check for this one. So we'll check for this one, option C. So we'll consider the function gx as follows. So gx will be here equals to 0 to x ft sin t dt. Now g0 is equal to e to the power 0 minus 0 to 1 0 to 0. Get it? If you put x equals to 0 0 to 0 ft sin t dt, this is nothing but e to the power 0 is equals to 1. This will be nothing but e to the power 0 equals to 1. Again if we put x equals to 1, so x equals to 1, so it will be e to the power 1 minus 0 to 1 e to the power 1 minus 0 to 1 ft sin t dt. So yeah, this is something like e minus 0 to 1. So this is obviously this one g0 is positive, right? So g0 is positive, greater than 0. Now this one ft sin t dt, this one lies between 0 and 1. Why? Because the same reason, ft lies between 0 to 1 and sin t lies between, in this interval 0 to 1 interval, sin t obviously lies between 0 to 1. So this value will lie between the maximum value possible is 1. So this the maximum value of this one, so maximum value max g1 is equal to maximum value possible is equal to e minus 1. So this is obviously positive. So this is positive, this is positive, so no sign change is occurred here. In this interval no sign change is occurred, both is positive. So this end 0 end is positive, 1 end is positive, so this cannot be true. So the value will not be 0 in this interval, correct? Yeah. So we'll check again for this one. So we'll check again for this one, d. So we'll take gx equals to fx plus 0 to pi by 2 ft sin t dt. Now for the value g0 equals to f0 plus 0 to pi by 2 ft sin t dt. Again this value lies between 0 and 1. So this is obviously positive, and the maximum value of this will be pi by 2. So the maximum value of this one 0. Yeah, the maximum value is possible is equal to positive, obviously positive, and also the minimum value is also positive. So the minimum value of g0 is also positive, not negative, because this value, the minimum value of this is 0 and the maximum value of this is pi by 2. So f0 is positive and this is positive, so g0 is always positive, correct? Again we'll check if g1 is positive or not. So g1 is f1 plus 0 to pi by 2 ft sin t dt. Again you can see that the maximum value is pi by 2 and the minimum value is 0. So obviously this one is also 0 and lie between 0 and 1. So yeah, this is also positive. So no sign changes occurred over here, so this is not true, correct? So these two is not true. these two is not true, this one is not true, this one is not true. So we will get over here this one and this one, A and B. A and B is true, correct? So for this one, A and B is true. These two options is true. So yeah, this is the solution for these two questions, question 39 and question 40, and we'll solve the next two question in the next video. So if you want to get in touch with this series, you have to subscribe this series and you have to like this series, so that yeah, more video will come again the next day. Like tomorrow will come the part 3. So this is part 2. Part 1 is before this video, so you can please watch this video, and this is the part 2 and part 3, and this series will go on. Okay, thanks for watching.